Welcome back. Today we're going to take a look at exercise 2 in SolidWorks 2020. As you can see here, the image of the model that we're going to construct is actually like a wheel, not quite like a turbine, but I guess like you might say a cast turbine wheel of some sort. Anyhow, it looks a lot more complex than it really is once you actually start building it. So first of all, those of you who are taking this course, if you are, then you know you should go to the Vertanux, VERTANUX1.com. You could go to Instructional Manuals, SolidWorks Basics, and it will open up the lesson for you. And the lesson begins on page 29. Now with this lesson, you can see what we're going to do is we're going to construct this with a profile that's going to be spun around. And what they call this is a revolve feature. Here you can see on the image that we have the profile. We have some dimensions. We're going to learn how to put those in. And we're going to also learn mirroring. Now, those of you who did Lab 1B last week actually got a taste of this already. So, but for those of you who didn't do the lab as of yet, this is where we're going to learn how to do mirroring. Now, there's two types of mirroring. There's mirroring of features and mirroring of sketch geometry, which is two-dimensional typically. And so we're going to take a look at both those methods today in this exercise and come up with this wheel that you see here. So let's begin. Go to New, Part, and hit OK. We're going to sketch this on the front plane. So select the front plane over on the left-hand side and start a sketch. Now, remember from last week, you could go to the Sketch tab up here and click on Sketch right here. You do not want to use a 3D sketch, by the way. All right, begin by clicking to the right of the line tool, and you'll find the center line tool. So select that. Move your pointer just above the origin on the viewport. And when you get the line of inference, that's that little dashed line, click and drag it straight down and connect it to the origin. Click to the left and about 4 inches to the left. Make sure it's horizontal. Click. And now hit Escape on your keyboard. Now to get rid of a line chain, by the way, it's just a double click, or you could hit Escape. Now we're going to go ahead and draw that profile. So take the line tool now. Hover just to the left of the origin, but on the horizontal center line. Click. Drag up a line about an inch in height. You see mine is like 1.05. Click. Drag to the left about 0.4-ish to the left. Click. Drag to the lower left about 0.8 to 0.9, but don't touch the horizontal center line. You want to hover above it just slightly. Click. Now drag this out about an inch. Make sure it's horizontal to the left. Click. Drag straight up about another inch. Click. Now this is going to be about 1/4 of an inch or so. Click. That's a horizontal line. And then straight down and connect it to the center line. Click. You could hit Escape on your keyboard once you've got that. So it should look like this. It looks kind of like almost like an airplane wing on one side. So what we're going to do now is we're going to learn how to mirror sketches across. Again, this is a review to those of you who did Lab 1B. So the way it works is you need a center line when you're mirroring 2D geometry across. And we have that. That's why we drew that. It's the horizontal center line. The vertical center line, by the way, is actually going to be used to revolve or spin it around. So we're not interested in that one just yet. But let's get this mirrored across. What you can do is you can click on Mirror Entities, and last week we actually saw a couple different ways you could do this. We're going one route. This is maybe the slower route, but it's okay. It's so you can grasp the idea. Now select the blue lines. Now, could you group select like with the window? Absolutely. You could click up here and drag across, but don't include any of the center lines with it. And i.e. meaning if you go from left to right, make sure that those center lines are peeking out of your envelope that you're making. Kind of like this, I'll show you. You can click and drag across like that. All right, so that's a quicker way rather than selecting each individual line. Now go to Mirror About, and we want to mirror it across the horizontal center line. So go ahead and select that. You'll see a yellow preview. And if it doesn't look right, hit Escape and try selecting those entities again. But now hit the green check mark, and now we have our profile. We could actually revolve it 360 degrees around to make a wheel, but it wouldn't be accurate just as of yet. We haven't added the dimensions. SolidWorks doesn't force you to add the dimensions, but it is a good practice, especially before you go into production, to add all the dimensions. But for conceptualization work, you don't need to add them if you don't want to. It doesn't force you to. So let's go to Smart Dimension. We're going to start and work our way from the inside of the wheel out. So select this vertical line here, and then select the vertical center line. Remember, avoid selecting points of any sort right now. There will be a time where I'm going to have you select a point, but just not now. Click here. Now notice if you leave the dimension between the two lines, it just gives you a distance between the two. Now when there's a center line, you get something special that happens here. If you move the pointer to the right, it automatically doubles that dimension. It's a preemptive sort of diameter dimension, you might say. We want that in this case because this will be a hole, which is a drilled hole essentially. So make sure you're to the right of the center line. Click. And now let's go ahead and type in the value. It's just going to be 0.75. So type in 0.75, hit the green check. And now if you drag that up here, you'll see there's no diameter symbol to indicate that it's a diameter as of yet. But if you want to add it, just move, after you select that dimension and move it, go over here to the diameter symbol and click on that. And it should put a diameter symbol in there. Notice the arrowheads automatically spread out outside. That's fine. Go ahead and hit the green check. Now go back to Smart Dimension. Click on this line up here, drag it straight up again. Avoid the points. Avoid the midpoint, avoid the endpoints when you're selecting. If you accidentally select those, hit Escape now. Try it again. Drag this straight up, type in 0.4. Now go ahead and select this angled line and select the vertical line to the right of it. Drag it straight down in this little area down. Look carefully where I'm dropping it. Click to release it. Go ahead and type in 18. That's 18 degrees for that angled line. Select these two lines here and here. Drag that through, and that's going to be 0.25. Now select this line here, drag this to the left, click, and that'll be 2 inches for the height. And now let's go ahead and dimension that line again to the vertical center line. Now remember, dragging it to the right of the vertical center line will give you a diameter, essentially what will be a diameter. So click, type in 5, hit enter. While it's still in a selected state, go over here and add your diameter symbol. Do you need to add the diameter symbol? No, it's an option. But for drawings, you want that on there because eventually this will be spun 360 degrees. It will be a diameter. So it's not required though. Go ahead and now select this line, drag this straight up. Now, here's something neat that happens with SolidWorks. They added this a few years ago, and it takes the last known geometry that you selected and combines it with the other to give you maybe a dimension, in this case, a 90 degree. We don't want that. It's just an added benefit tool. Just hit Escape one time on your keyboard, the upper left. And now you could drag that dimension up again. Click, once you center it, make it 0.25. You could drag it out. It is a good practice, as I stated in exercise 1, to lay your dimensions out how you would like to see them on a print. Not just for the print purposes, which you might make later on down the road, although prints are starting to become extinct, you might say, but they are still used in many companies, so it's good to keep your practice up on making a drawing. But anyhow, it's also nice just to see it clearly. So I'm going to click on these dimensions and drag them and just relocate them so they look a little nicer. Now here's something you don't always see me do. I'm going to have you select a point this time. I want you to select this little vertex in this corner. Look carefully what I'm hovering over. When it turns orange, Click once. Now click on the vertical center line. Drag it up here. Make sure it's to the right of the center line so it gives you a diameter. Click, make that 2 inches. And now over on the left here, click on the diameter symbol. Notice you could add dimensions to, not dimensions, I'm sorry, you could add notes inside this little box here if you wanted. You can make an inspection dimension. There's all sorts of neat things that are in there. So let's hit the green check. And now let's lay these dimensions out so we can see them a little bit easier. Okay, now we're ready to revolve this 360 degrees. By the way, if you're having difficulty, maybe when you were sketching you didn't have points snapped together, there are methods. You could hit escape and try and drag them to connect them, or you could add relation by control selecting both endpoints, and on the left go with coincident. But what I sometimes recommend to students is if yours is really way off and you're not seeing it shaded internally, that indicates that you have a sloppy sketch. And there might be lines on top of a line, or there might be a fragment of a line. Rather than hunt for that, you're starting off, you need to know how to make good quality sketches. Wipe it clean, start new, or just hit escape, click and drag a fence around everything, hit delete on your keyboard, it'll wipe it out. By the way, you could delete anything just individually. You could click on a line, hit delete if you like. But I recommend that, and I know students are like, well, that's not the way you do it usually in real life. Well, once you become fluent with this, yeah, you're going to be able to figure out how to troubleshoot. And I'm going to show you some of those tricks as we go. But as a new user, you're far better off almost scrapping your old sketch and starting fresh, because you're going to learn from your mistakes. So don't think of it as a waste of time. Think of it as a learning experience. All right, now what we're going to do, we're going to revolve this 360 degrees. Go ahead and select the vertical center line. Now, before you do that, make sure you're out of the dimension tool. So you might want to hit escape before you do that. Select that vertical center line. You're pre-selecting it so that, because that's your spin center. Now let's go to the Features tab and find Revolve Boss Base. Click on that, and you'll see it starts to give you a preview of the spin. Hit the green check, and now hit F on your keyboard, and then click somewhere on the screen off of the part to remove or to freshen up that screen a little bit, remove some of that excess geometry. Okay, so here we have our wheel. Now let's add some features to it. Go to the Fillet tool and set your fillet. If you don't have it already set to full preview, turn on full preview. Keep the fillet at 0.1. And SolidWorks employs something really unique out there in industry. When you're selecting edges to fillet, you don't always have to select an edge. You could select an actual face. So like this face that I'm hovering over, take a look to the right of my pointer. There's a little square, a blue square. That indicates a surface or a face that you're selecting. What it's going to do with this, it's going to take the topology, which are the edges, and automatically fillet those if it can support that type of a fillet. So go ahead and click, and you'll see the preview show both of those are filleting. Be aware you don't always want this. Sometimes you just want one of the edges. So at that point, let's practice down here. Click on this bottom left edge. Now, I talked about this before. I always say the Superman X-ray vision. Use your X-ray vision, just hover over this edge where you think it would be without having to rotate the part. Now, if you remember, rotating the part is pretty easy. You can use the arrow keys on your keyboard. You can use the middle wheel. If you push it down and hold it, move your mouse left, right, up, and down. You could do it that way, but you could also select through the part like that. Now, let's go ahead and select this one. You can select this face right here. And now this next one will only let you select edges through a part. So you might want to rotate, like if you use your wheel, hold your wheel down like it's a button, move your mouse upward, and you'll see the underside now. Go ahead and click on that tapered surface right there and hit the green check. All right, let's add a bigger fillet now. Go to the Fillet tool and set it to 0.5 this time. And select this edge here and use your X-ray vision without rotating, or at least try. Select that edge right below it to add the fillet. Now, if you rotate, you can see it's just those two internal edges. Hit the green check. All right, now our wheel is starting to look a little bit more complex. Let's move on and learn about the rib tool now. The rib tool is more of an advanced tool, but it's very useful for plastic parts or anything really that has structural ribs built into it. Let's make some ribs in here. Select this face. You need to select the flat face for it to rest on. Now, one of the mistakes that new users make, and I made this mistake years ago too when I was first learning this, is that I thought, well, the ribs, we want them to build upward from the bottom up. That's not the case with the rib tool. You want some sort of plane that's hovering above where basically the rib ends. And then it's going to extrude down to the surface or the floor of the part. So by selecting this face, we're doing that. Go ahead and start a sketch on that surface. Hit your space bar and go to the top view orientation. Now, if you want, you could also click right here on top, or Control 5 is the fast key. Now, take your line tool, and I want you to find, go from the center, but don't click yet. There's one edge, 2, 3, 4, 5. So about the 5th edge is a good one. Find the quadrant point that highlights in orange. Click, and then find the quadrant point to the next closest edge. Don't bring it all the way to the outside. What we're trying to do is encapsulate the line in between the walls of the wheel. Because if we go beyond the wheel, or if we even sometimes touch the wheel, if there's a taper, you have some weird things that could occur. Sometimes it just fails to add it. So once you got that, go ahead and hit escape. Now let's rotate this. Hold your middle wheel down, move your mouse to the left, and maybe to the upper left. And now you can see that line is just hovering there. Now we could have drawn all of them in if we want, but we're going to actually learn how to pattern here too, a little bit ahead of schedule. Normally patterns are circular patterns, or arrays are covered in exercise 4. I'm showing you a couple little tips and tricks ahead of time here. So once you have that line, now go to the features tool and go to rib. Now, by default, you want the rib to be normal to sketch in this case. That means it's going to thicken it from the width and go down. Notice this, you can set it, we'll leave it at 0.1. Those of you who are taking this class are new to engineering. When you're dealing with plastics, remember there's a 60% rule. If your wall is 100 thousandths for most of the part, then you would want actually the ribs to be about 60 thousandths or less than. So we're going to just keep it at 0.1 because our walls are actually 0.25 thick. So we're in pretty good shape. And that's just to keep, when shrinkage occurs after the plastic is solidified, sometimes you get sink marks. In this case, we're not going to have that issue. But that's just a little quiz for those of you who are going to take future classes. We're going to talk about that in more detail. This is actually just a SolidWorks class, not really necessarily about engineering. Okay. You could also add draft. We're going to leave the draft off. You would have to hit this little button right here. Hit the green check. And now look at that. It filled in that rib. You can actually see the original sketch floating there. If you click somewhere, it'll disappear. Okay, we're going to mirror that over to the other side, and then we're going to pattern these in an array. So let's go and select the rib. You could select the side of the rib, or you could select the rib from the feature tree on the left, like I did. Just one click. Now, go to mirror over here. Now, the mirror tool, when you're working with features, which are three-dimensional features, like this is a solid rib, it's different than the mirror inside of a sketch. Remember, when you're doing a sketch, you need a center line to mirror across. Well, here, we need a plane or a surface. So the way we developed this part, remember, we had off the origin, which there's a top plane in there, in theory, that's running right through the center, and we can mirror across it. So we need a plane. So what I want you to do is click over here on your feature manager, and you'll see the feature manager will appear onto the screen because we have our editor manager right here. So for mirroring. So let's go ahead and select the top plane for the mirror face plane. You'll see it mirror across. You see the preview down below. Go ahead and hit the green check. And now we've just mirrored a solid. So note, for sketches, you use a center line to mirror across. For solids, you use a plane or a surface if it's available. Okay, now we're going to go ahead and mirror, pattern this. So you'll find under linear pattern here, if you hit the little arrow, you'll find circular pattern. Click on that. Now with the circular pattern, we're going to go ahead and I want you to go to see there's pattern axis that it's looking for. But before you do that, click on equal spacing, put in 20 for the number of instances right here, and 360 should automatically feed into there after you hit equal spacing. If not, make sure equal spacing is selected and put in 360. Now, select features and faces to mirror. It already had my mirror in there in this box, so click in that box again. Select the rib too. We want both the mirror and the rib selected. If you don't see either of these, just clear them out by right-clicking and select the rib and the mirror. Now, for the direction. Go ahead and click up here for direction 1 in that blue box. Or make sure it changes blue. That means it's going to input whatever we select. Select the outside of the wheel. And now you can see a preview up here. Hit the green check mark. And now you can actually see those ribs have pattern. Now let's have a little fun with this. First of all, let's save this. To save it, just go to File and do a save. You could do a save as if you want to rename it to something if you've already saved. But I have a folder already created for my SolidWorks Basics. You could locate wherever you want. If you want to put them on your desktop, that's fine. Or create a folder. You could just right-click on your desktop and go to New Folder and name it SolidWorks, whatever you like. Now this is exercise 2. So in short, just capital E 2 and hit save. So we've saved that part. Now let's add a little bit more to it to make it look interesting. Select the front plane again and start a sketch. Hit your space bar on your keyboard and go to the front view orientation, or Control 1 is the fast key if you want to just do that. Now we're looking at it from the front. You're going to first go to center line again. We want to draw a center line and make it vertical. Some of you might be asking, isn't there one already in there that we could use if we're going to make do of a revolve again? And yes, it is. It's just that it's actually easier just to redraw it sometimes. So we'll go through that actually. Exercise 4, we'll talk a little bit about that. Other options. Okay, now go to the circle tool. Find the midpoint of this left edge. See that little orange square? Click, drag on a circle, dimension it at 1 inch in diameter. Now, go to the circle, draw a circle up here, and again make that, rather than adding dimension to it for the diameter, don't worry about that. I'm going to show you another trick. But we do want to position it. So click on the center point of the circle to the vertical center line. And we could make this a full diameter. We're going to go ahead, we'll make it a full diameter, what the heck. And let's make it 2.75. All right. Actually, let's make that 3. Just double click on the dimension if you change it to 3. And over here on the left, you could add the diameter symbol if you like. Now, we want to mirror that across. So hit Escape. Go to the center line tool again. To the right of the line tool, hit the little arrow, go to center line. On the origin, click, get the orange dot, and get to the center point of that other circle we drew. Now we're going to use that center line to mirror across. Now, could we have drawn another circle? Absolutely. You would just have to dimension it. This practice is very nice, though. Click, hit Escape on your keyboard, then select this circle. Hold Control and select the horizontal center line, and let's mirror it across again. Go to Mirror Entities. Okay, now to make all 3 of those equal, select the circle here, hold Control, select this circle, and over here on the left, find Equal. If Equal doesn't show up, hit Escape a couple times and reselect those. But you only need to select the 2 because the mirrored entity automatically has a symmetric relation back to the top circle. So whatever that is, it's being driven by. So now they should all turn black. Select the vertical center line and advance. Go to Features, and now go to Revolve. Cut. Hit the green check. And then click somewhere here. And now look at that. We now have our wheel, and it looks much more complex than it really is. So we've done some pretty neat things here. All right, now what we're going to do is we're just going to make sure you save that. Great portfolio piece. If you want to do the photorealistic rendering, remember you could go, if you have it, SolidWorks add-ins, Photoview 360. If that's grayed out, that means you don't have it. It's only on certain licenses. It's an extra add-in for SolidWorks, so not everyone gets it unless it's procured that way. Now go to Render Tools. If you have it, go to, actually don't worry about the scene editor yet, but what we're going to do is we're going to click somewhere on the part, and then I want you to go to the beach ball with the pencil on it. Hit the little arrow to the right of it, and find at the very bottom where it says E2, and click on that silver sphere that's there. Now on the right here, you could select the high gloss, plastic, or this one looks really neat. If you want to challenge your system, your computer system, go to the glass and hit the little arrow and find thick gloss. Select clear, thick glass. Hit the green check, and now hit integrated preview. Now here, always turn on perspective view because it's going to give you a vanishing point, make it look more realistic. If you leave it off, it looks a little like, oh yeah, that was a photo rendering. Just sit back and let this render. Again, my computer here is pretty significant. It has 16 cores, 32 threads. It's the Ryzen 9, so it's very fast. Those of you who have other computers, it might take 10 times that long length of time before it's done rendering. Again, one of the benefits of having the latest and greatest computer, although they're very expensive. SolidWorks doesn't need a very high-performance computer to run it unless you're doing renderings all day. Okay, so there you can see our photo rendering. Great portfolio piece, which we discussed in last week's exercise. Let's take a look at the training guide, and let's look at what we have for the labs. Now, we have a bolt right here, and then we also have the quiz to practice. So let's take a look at the bolt first. And we have a bolt that's 2 inches in height with the dome on the top, 1.7 for the shaft, and the button top there, you can see some dimensions. Let's get started on that. Go to New, Part, and hit OK. And select the front plane, start a sketch. Go to the center line tool and draw a vertical center line. About, the bolt's going to be about 2 inches, so maybe 3 inches in height, or 2.5, works pretty well. I'm going to hit F on the keyboard for zoom to fit. Now I'm going to go to the line tool, and I'm going to draw up a vertical line 2 inches. Actually, not 2 inches. Let's, I want to show you the dome tool. So maybe less than 2 inches, maybe around 1 3/4 or something like that. Okay, then go straight across here. Let's take a look at the drawing before I get some dimensions here. We could see that the diameter here is 1 inch for the overall head, and so that would mean we want to go about a 1/2 inch straight across. Click about 0.1 down straight, and then get in right about halfway. Click, drag this straight down, infer to the origin, click, and click on the origin, hit escape. We're going to do Revolve feature, of course, here. Go to Smart Dimension, and dimension this at 1.7. Oops, I accidentally selected that center point. Let's look at the drawing. That's going to be 0.1. So stay away from the points. Just make that 0.1, hit enter. And let's see, the diameter is going to be selected from here to the center line, make that 1 inch. And then the actual diameter of the bolt here, let's see, oh, 0.5. So down here, we could dimension from here to the center line, and that's going to be 0.5. Now, if you're not getting this to give you 0.5, just dimension it from in between there, make it 0.25. If you can't get that, that's because you might have accidentally selected the object line, which is a solid line, versus the center line that's poking out at the top. So the center line gives you that advantage of getting the diameter in there. So I'm actually going to add the diameters here. So I'm going to click. Don't click just on the dimension. It will edit it. Click on that, the arrowhead or the arrow line there. And let's go ahead and select the diameter symbol for that too. And now we could go to features, and since there's only one center line for our spin center, go right to revolve and it should automatically spin it for you. Hit the green check. Now I want to show you the dome tool. This is really kind of a fun little tool that's inside SolidWorks. Go to insert, features, and find dome. Now the dome's going to be 0.15, so we could go ahead and put that in, or just select this face right here. And you could roll it. Look at that. You could actually make it a full sphere. It looks like a golf ball on tee. But let's go ahead and get it down to 0.15. I'm sorry, 0.15. Hit enter. And so we've got our dome. Now elliptical dome changes it and makes a tangent off the edges. That's not how our drawing is indicated. Normally you would just draw an arc at the top and dimension it like I have it in print and then spin it along with the profile. But this is just one of the tools I wanted to show you as an addition, which is kind of neat, the dome feature. Okay, now we need to make, let's look at this drawing again. Let's see. Oh, you know, it is a 0.15. It's the difference right here. You need over 2 inches. So let's get that done there. Let's see, we're at 0.8, so 0.2. So just double click on the dome. Now here's the neat thing about the software. If you're doing, this is a very easy math computation. You can just do this in your head. But if you're not sure, remember we have 1.7 and we have 0.1 added to that. So that's 1.8. So we could type in 1.8. Now the overall is 2 inches. So you would be able to type in -2 and get the dimension. Let's do that. I want to show this to you. Hit enter. Okay. Oh, you know what? I had, oh, I'm sorry, the dome. That's right. Let's just go ahead and put in 0.2. It is supposed to be 0.2, and hit the rebuild button up at the top there. But note that in those dialog boxes, you could actually type in little equations in there. So if you're not sure what they are, hit the rebuild button and you'll see it will inflate the dome to 0.2. Okay, now we want to go ahead and put in that little slit for the screwdriver. So select the front plane, start a sketch. Now, this is kind of challenging for most students because they think they need to spin it, but you don't want to spin it or revolve it. You're actually just going to cut it through. So again, we use the center line, but this time for mirroring, not for revolving anything around. So draw a vertical center line like that. Now take the line tool and start down here, click, drag it across, and connect here, just like that. It doesn't matter how high you peek out, as long as it's beyond that. You could actually have it snap to the top, but anyhow, let's go ahead and select this geometry here. You could control select this vertical center line, or watch this, click from right to left and drag, and it selects everything in that envelope, anything that's touching the envelope. Go over here to mirror entities. It should mirror it across. Now let's add some dimensions on there. So the width down at the bottom is going to be 0.1. The distance from here down to here is going to be 0.15. And the angle from here, oh, I accidentally selected that. Let's hit escape. Let's go back to smart dimension. From this line to this line, get it right in the center, make that 30 degrees. Again, the height doesn't really matter as long as it's clearing the top. Sometimes I even leave the top off. That way it just goes through. But now let's cut that. Let's go to features, extrude cut. And instead of blind, we wanted to go both directions because look at that. It's only going to cut out the backside. So go through all, both, and hit the green check and click. And now you have that completed. With the exception, there's a little chamfer here. Let's, underneath fillet, go to chamfer. And we could have drawn the chamfer in too, but it's just easy to put it in this way too. And it's just 0.03 at 45 degrees on the bottom edge. Oops, you want the actual edge. I selected the face there and it chamfered the top edge, which we didn't want. Hit the green check. Now, there are threads, and there's a thread tool that came out about a year or so ago. It's excellent. I'm not going to show you how to do that just yet. You could watch a video on it if you like. There's 3 different ways to do threads. Actually 4 if you count a cosmetic thread. Like, let's say I wanted a cosmetic thread here. You could select that face, you can actually go to the appearances and go to the face because you want to see a thread on there. Now, if you scroll down to miscellaneous, and I believe it's pattern, you'll see screw thread. Click on that. Now you can actually grab these and adjust the thread appearance. And this is just for visuals. It's not really, we're not putting a real thread on. We do cover threading in exercise 13, if I'm correct, of the advanced class. Otherwise, just watch a video on threading. You typically don't want to add real threads unless it's going to be manufactured. If it's a unique thread, because usually you just put a note at what the thread is, because true threads, real threads, are very complex and they soak up system resources. It will really slow down your computer, especially if you have 1,000 bolts with real threads on them. It's going to slow everything down, so just be careful with that. That's why usually cosmetic threads are just fine. And that is lab 2. You could go to save, and let's say this is L2, capital L2 for lab 2. And now the quiz. This quiz you're going to take, I'm not going to put it in this video, but I will maybe make a video after everyone takes it to show you how to do it. But if you're looking in the book, and you don't have to do these IMT projects, those are for a different class. Don't worry about doing those. If you want, you can, but you don't have to do those. There's no extra credit given in my classes for those. If you want extra things to do though, those are good little projects. All right, so here is the quiz. And if you recall last week, I showed you how to you could download this. And basically, once you open it and launch it, you could actually right-click and rotate it so you're looking at it straight. But this is a 6x3 block. It's 1 inch thick. It has a post on the top here with the through hole with all the dimensions given. I will post a video of that. If you really want to see how it's done, you could look at exercise 2 of SolidWorks 2019, and I actually do have a technique in there so you can see how it's done at the very end. But I'm not going to put it in this video because I want my students to actually be challenged and try and make this. Because remember, when you get in real life, there are no videos to help you actually model these things. I mean, there are videos, but not of the exact part you're going to be modeling, most likely. Okay, and that concludes exercise 2.